Before we move on, we're going to do a quick introductory into pressure. So we're going to be talking about pressure and pressure gauges a lot throughout this course. And if you see on this pressure gauge, it's showing 0 PSIG. And that PSIG stands for pounds per square inch gauge. It's a gauge pressure. Now it's showing 0 PSIG because it's measuring a pressure differential. The difference between the pressure on this side versus the pressure on the outside is equal. There's 0 pressure difference. But in reality, this gauge is still under pressure. We've spent our whole lives under pressure and we've never realized it. We live under atmospheric pressure, 14.7 PSI atmosphere all the time. So PSIA is considered pounds per square inch absolute, or also called atmospheric. So we got to think about a cubic foot of air, 1 foot by 1 foot by 1 foot air. So if we imagined that this was air, it's 1 foot by 1 foot by 1 foot. Now if we put another box on top of that of air, and then we put another box on top of that one, and then we put another cubic foot on top of that one, and then we keep going on and on and on for as far as we can see, all of these cubic foots of air have weight and they're pushing down on us. We've spent our whole entire lives with this air and this weight pushing down on us, and to us it doesn't feel like there's anything, but it's still there. If you think about a fish swimming in the sea and you pull him up from the very deep in the ocean, he's under that pressure of water. Cubic feet of water on top of him, he doesn't realize it until you pull him out of the water. And all of a sudden there's very little pressure on him, and you'll see their eyes bug out and some other horrible things, but that's part of that pressure. So we're under pressure all the time. Now we need to be thinking about being under pressure, and that pressure gauge is nothing more than a pressure differential. So it's showing 0 PSI gauge, but it's really 14.7 PSI absolute or atmospheric. So here I have a couple little examples. These pads are sitting here on the table, and if I try to pull these up, it's very difficult to pull them up. This one the same way. If I try to pull this up, it's very difficult to pull this up. Now the catch is people think that a vacuum is something holding it down. But that's not true. A vacuum is just a pressure differential. If I pull this up from the very edge, it allows 14.7 on both sides and there's no pressure difference. But if I try to pull it up from the very center, there's 14 PSI per every square inch of pressure pushing down on this pad. So when I try to pulling it up, I'm trying to overcome all of the atmospheric pressure that's pushing down on this. So it's not really, there's no such thing as a vacuum. It's just a context for us to think lack of atmospheric pressure. So here, this is atmospheric pressure pushing down, atmospheric pressure pushing down. So we need to understand that because now we're going to do some little tests to modify it. If you think about pressure, and we've all had a balloon before that we've inflated, and if I inflate this balloon inside this jar with a hole in it, no big deal, it goes back. It has elasticity, so it pulls it back down. But if I was to inflate this balloon and then plug the other side, we can see the balloon stays inflated. There's not enough pressure difference, and so that latex is causing it to still be expanded. It's not that there's a vacuum pulling it down. As the balloon tries to deflate, there's a pressure difference now. There's more pressure on the inside versus the outside. Now if I allow more atmospheric pressure on this side, it will allow it to equalize and deflate. So no real such thing as a vacuum. We're going to talk about vacuum a whole lot more a little later on. This is just an introductory to it. Next, what I want you to do is think about a balloon. So here we have a balloon, and there's 0 PSI gauge pressure difference between the inside and the outside. But in reality, there's 14.7 PSI on the outside of this balloon, and there's also 14.7 PSI on the inside of this balloon. So what we're going to do with this balloon is we're going to go ahead and just tie it off just like it is so that we hold everything together. So now, secured off, there's still 14.7 PSI on the inside of this balloon, although to us we consider it deflated. Now the next thing we're going to do is put this balloon inside of our vacuum chamber, and right now it's still deflated because there's 14.7 PSI here. What we're going to do is put this in a vacuum chamber, and I'm going to remove the atmospheric pressure from inside of this container, and let's see what happens next. So we have the balloon in the vacuum chamber, and what we're going to do is turn on our vacuum pump to remove the air that's inside the chamber. So So now as we start pulling air from inside the chamber, there's a pressure differential between the inside of the balloon and the outside of the balloon. Now the balloon is expanding because the 14.7 that's inside the balloon is pushing it out against the lower pressure on the outside. So there's a pressure difference now. As we remove the atmospheric pressure, we can physically see that the balloon is starting to inflate. And it's the same amount of air inside the balloon, and it's the same number of molecules inside the balloon. It's just a pressure difference, and that's the key. That's what I want you to see in this video. We'll do it again from the outside. We'll seal off our vacuum chamber, turn on our vacuum pump. And as we remove air from the outside, the pressure from the inside is now greater, and it starts pushing against it. And now we're expanding our balloon. And we'll shut our pump off. We're going to reintroduce atmospheric pressure. And you can see that the balloon goes back to its deflated position. We'll try the same experiment again. And what we have is a fan in here, and the fan is blowing or moving the tissue around so you can actually see the air movement. We're going to put this in our chamber and we're going to seal it up. We're going to turn on our pump. And what we can see is that the tissue is no longer moving around. So I'm going to take the whole entire vacuum chamber and shake it up and put the fan right up against the tissue. And we also see that still we don't have any change. So once we shut the pump off and let air back in, we can see that the air is moving around from the little fan, and the air rushing back in makes it move as well. So air has weight because air has the molecules on it. One more little thing that we're going to do is we're going to put the camera inside. And we're going to unplug the microphone. So hopefully you can hear the fan motor running. What we're going to do is put the cover back. So for us to have sound, we must have those molecules touching each other. So we're all under atmospheric pressure. And as you go up in altitude, there's actually less pressure being pushed on you. What is really cool about that as well is thinking about the temperature and pressure correlation. As you go up into the mountains, there's less pressure on you, so there's also less temperature. So the temperature drops. As you go down in the atmosphere, there's more molecules of air pushing on you, there's greater pressure pushing on you, so the temperature goes up. And Death Valley is one of the lowest places on Earth, not the lowest, but one of the lowest places on Earth, and it's very, very hot there, especially in the summertime, because you have all this atmospheric pressure pushing down. There's more pressure against you, there's more temperature against you. Also, not too far from Death Valley, you can go up into the mountains. And as you're going up into the mountains, there's now less molecules of air on top of you, so there's less pressure on you, and it also, you'll notice that the temperature is lower. So you think in places like Denver, Colorado, you're up in the mountains, you have less pressure physically on you. So what I want you to really understand, let's do a quick recap, is we're all under atmospheric pressure. How high and how low we go affects that. PSIG is pounds per square inch gauge, and PSIA is pounds per square inch absolute or atmospheric. A pressure gauge just reads the difference for the inside versus the outside.